Acha, chalo, let's start. So today we have to see the instruction set for 8051. Getting? And that will be useful for your programs as well as in your practicals. Fine. So let's start. Yeah. That's simple. Once we have done that 86 ka instruction set, so now you will feel this one as a simple one. Fine. So let's see first, once again, that the instruction set is divided into the different group. So first we are going to see that arithmetic instruction set. Okay. So whenever I say the arithmetic, so it will just perform addition, subtraction, multiplication, and division. Fine. So let's see how that instruction set we are having. And one more thing, one more important thing in 8051 instruction set. Do not make your own instruction. You have to just strictly follow the particular one. These are the instruction which are available. Okay, you cannot make your own instruction. ये सी नहीं तो ऐसा कुछ नहीं that wherein we can just program our code in our own functions and we can use. No, this is the assembly level language, and here we have to use the instruction which are already defined, and by using that only we have to develop a program. Getting it? Okay. So let's see. So first of all, we start with the add. So in an add, we are having these different things. Let's see. In an add, we are having 1, 2, 3, 4. This 4 you can see. First 4 instructions. These are for the add. Okay. So what are the different types? Let's see. Just keep it like this one so that both will be available to us. Yeah. This is my board. Okay. Fine. Okay. So whenever I say add, we have done some arithmetic instruction. Fine. So we know like add is a comma rr. Now keep in mind here, the notice that whenever I say RR means what? R means small r. A small r actually range from 0 to 7. So it can take any register. And whenever I say RP, so means that P will take only 0 or 1. Getting it? Okay. So whenever I say the RR, so this small r means what is it will be any value between the 0 to 7. And this P, if it is a P, then it can be 0 or 1. Fine. So whenever I say add A comma RR, what will happen? Come on, फटाफट आज खत्म करना अपने को ये. Add A comma RR.
Value in RR will be
Yeah, so it will just add the kind of accumulator with RR, and jo bhi RR means for the register, and that answer will be stored into the accumulator. Okay. Once again, keep in mind here we cannot make your own instruction. Okay. Let's suppose if I do write like this one, what will happen? Add RR comma A. What's the difference in these two? Yes, what will happen? Come on, fast. Add RR comma A. सर ये बोलते जाओ wrong तो wrong मगर बोलो important है.
Sir,
The
this command
addition
will
will
not
take
work.
place.
हाँ, addition will take place and then answer will be in
Accumulator only.
no. So this kind of instruction is not allowed. This one is a wrong. Okay, we cannot interchange the place. Okay, so whenever I do any arithmetic or logical instruction, in arithmetic it is compulsory that destination must be accumulator only. Getting it? In arithmetic instruction, it is compulsory that destination must be accumulator only. You cannot have something like this one. Keep in mind, assembly language में क्या होता है? ये जो left side में जो भी है, that will be acting as destination, wherein we have to store that answer. Okay, so if I say add A comma RR is fine, but if I just interchange the place, which we used to do in 886, but यहाँ पे allowed नहीं है. Try to understand. इधर RR नहीं चलेगा. If it is arithmetic and logical instruction, for arithmetic it is compulsory कि वो accumulator ही हो. ठीक है? So then here we can change this particular one. The right side वाला बंदा अपन change कर सकते हैं. ठीक है? Just like this one, that add A comma address. We can just add the content from the address also. So these are the now variations are there. Okay, then we can just say add means for this if I just give the example it's just like this one, add a comma 30h. Now if I say like this one, add a comma 30h, what will happen? Add a comma 30h, what will happen?
30h will be added to the contents of A and it will be stored in A.
Very good. So here 30h, now this is going to be acting as a location. Why location? Why not immediate data? Because we have not written that hashtag before it. Okay, so here it will be acting as a location. So location का content A के साथ add करना and answer A मिला. It's very simple. Okay, likewise we can have add A comma @rp. Now whenever I say the @rp means what? Now this instruction can either add A comma @r0 or add A comma @r1. Okay, now I hope you have understood what does it mean. I need not to explain it. ठीक है, अगर डाउट रहेगा तो प्लीज इंटरप्ट मी एंड आस्क. I suppose this one is a simple instruction, so that's why I'm just avoiding it, nothing else. Fine. Then we are having one more type of writing, just like add a comma hash n. Okay. Now whenever the hash n means what? This is the immediate data. So if I just say example for this one, this is a add a comma hash 30h. So there is a difference in this particular and this one. So here the 30h will be acting as a location. At that location we have to go data उठा एक के साथ add कर and answer ये डाल. Okay, but if I say add a comma hash 30 means what? This is the 30 which you have to add with the a का content and जो भी answer रहेगा once again keep it in a. Getting it? So these are what the 4 variations we are having for the add. Okay, likewise now this one is a simple add. Likewise we are having ADC, add with carry. समझो. Okay, we have to cover all the 100 instruction. I want सभी के सभी 100 instruction आपको पता हो. Getting it? So add with carry. अभी whenever I say the add with carry, इसका meaning क्या होता है? It's just like add a comma RR. If I just write like this one. Okay, so what does it mean? Add मतलब a का content RR के साथ add करने का, and it will just add the carry which will be there मतलब previously in the carry flag, or which will be because of the any previous operation. Getting it? ठीक है, it's not कि मतलब try to understand what do you mean by this a plus RR plus c, इसका meaning क्या होता है? Try to understand. ठीक है, इसमें let's suppose if I do like this one, 58 plus 92, समझो, try to understand. Let's suppose 58 plus 91. ठीक है, here it will be the 9. Now 5 plus 9 means what? 14 na? So it's a 4 and here 1. Okay, so do not say कि this carry you have to add over here and you have to make it as a 50. It's not like that. समझो. Okay, it's just like 8 plus 1 if I do 9, yeah fine, but 5 plus 9 if I do 14, so 4 the carry will be 1. So we need not to add we need not to add this particular carry in this one. Are you getting it? Let's suppose my A ka content is 58 and RR ka content is 91. Okay, so if I'm just adding this one, now here the carry which is generated over here, we don't want to add this one. We want to add the carry which is generated by the previous operation. समझ में आ रहा है क्या? ठीक है, so if I just add this particular carry तो फिर आंसर गलत आएगा. Getting it? ठीक है, so this carry is going to be of previous operation. Add with the carry, it's of previous operation. Getting it? ठीक है, so likewise in ADC also now we are having this 4 type. You can see over here in this PDF. Okay, so in ADCSO is add with carry. Sorry, it's just ADDC, add with carry. Getting it? Okay, it's add with carry. Fine. So we are having once again the same 4 format. Okay, so we have just done with the addition ka instruction. Okay, so addition may we are having this add and add with carry. Okay, then in this 4 variation and in this also 4 variation. Fine. Then we are having some more. There's a da. Now I hope everyone understand the da. Do I need to explain this one? Da. याद है da? Decimal adjust after addition.
Yes.
याद है ना? Everyone knows this da. Da का function क्या है? So what is the function of da is that what are the content in the accumulator which is in a hexa form, we have to just convert into the decimal form. Getting it? So what is the function of this da is that whatever the content in that a means what are the answer in the a after that addition. Getting it? Okay. So that we just want to convert into the decimal. Okay, so what is the content of is means whenever I apply the da, what will happen once again? What is the content in the hexa in this particular one means accumulator that will get converted to the decimal. Okay, but it's not key that we just convert each and every accumulator content. Means let's suppose as I told, if I just do 30h plus 20h. Now here the answer is going to be the 50h, but it will not convert this one. I have told you the rules for the da. Okay, what are the rules for the da? Anyone? To convert into the decimal, what are the rules when it will do that adjustment? What are the rules for the da instruction? This one is very important instruction, guys, and I will ask in a viva as well as in practical. So I will just ask you to execute something for this one and show me the result. Yeah, what is the rule for the da? Guys, I have explained this one in 886. I don't want to explain it again. So da is a decimal adjust after addition. Getting it? Okay. So how will it adjust into the decimal? Just like this one. Now if I just do the 30 plus 20, now in a decimal normally also answer we get 50 only. So I don't want to adjust this one. Okay. But let's suppose if I do like this one, 08 plus 04. Okay. If I do in hexa, what will be the answer? Anyone? If I just do 08 plus 04, if I do in hexa, answer will be what? Answer will be what? It's a 0C, na?
0C.
it is going to be 0C. ठीक है, but this is not the normal decimal answer, or this is not the correct answer which we do in a normal life. ठीक है, means if I just ask some normal people to do that 8 plus 4, which is at 12, so we want to display that 12. So in that case, now the die will come in picture. Now this 0C will be adjusted to the 12. ठीक है, how does it adjust? How it converts that 0C into the 12? Come on, guys. Yeah, so the adjustment के लिए there are two rules for the lower nibble and the higher nibble. ठीक है, in the lower nibble the da will be adding 0.6 for the two conditions. First one, if that lower nibble is greater than 9, first case, and the second case, or that auxiliary carry flag is greater than is equal to 1. Getting it? Okay, so in a lower nibble, now here you can see the lower nibble, it is what, C, which is greater than 9. So here it will just add the 6. So if I just do that C plus 6, so in a hexa it will just show that 12. Getting it? And which is going to be the correct answer. Fine. So keep in mind da कैसे काम करता है? It just works on both the nibbles. ये दोनों nibble पे, ठीक है? For the lower nibble, the rule is that we have to add that 0.6. But whether the lower nibble is greater than 9, or second is that auxiliary flag is equal to 1. Auxiliary carry flag means what? Where the carry from here to here is 1. Okay, then it will just add a 0.6 to the lower nibble. Okay, and for higher nibble, it will just add a 60 to the number. But for that, the conditions are first one that higher nibble should be greater than 9, and the second one, carry flag must be equal to 1. Then in that case, it will just add that 60 to the number so that we can get a normal answer. Fine. So that is what the function of da. Okay. Then we are having another arithmetic instruction. There is a decrement. Fine. So in a decrement, we are having decrement A, but we can decrement accumulator. Okay. And we are having decrement RR. We can decrement any register, and we are having decrement address. Getting it? Okay. But we can just decrement the address ka content also. Fine. And one more, we can decrement at the rate RP. So these are the four variations which you have seen. Okay. So we have seen add, then add with carry. Fine. Then we have seen a da, and then decrement ka variations. So decrement we are having, just come to the PDF. So decrement, you can say decrement A, decrement RR, decrement address, and decrement RP. Fine. So these are all the arithmetic instruction we have seen so far: add, C, and decrement, and da. Fine. Then we are having division. Div AB. This is a division kind instruction. Okay. Now the div AB is going to do what? A divided by B. Now here in a division, we are just having only one instruction, that's the div AB. Do not make by your own that div A R0, then div A comma RR, or div A comma hash n. No, we do not have this all instruction. Try to understand. That's why starting only. Do not make instruction by yourself. You have to use the instruction which are already defined. Fine. So we are just having only div AB. That's it. We do not have any other instruction for the division. Fine. And it is going to divide that A divided by B, and the answer will be in A and B. So whether A quotient रहेगा, B में remainder रहेगा. Let me just check. Achha, it will do that A divided by B, and you can check it in Keel also, means whether the quotient is in A or B. That you can check it out. Okay, but we are having only one instruction for the division, that is a div AB. That's it, and it will divide A by B. That's it. Fine. Then for likewise increment, likewise decrement, we are having the instruction for the increment also. So we are having like this one. Let's see. Yeah. So decrement A. So we are having increment A. Then increment RR. I hope you are getting it. If you do not get any instruction, then please ask. I will just stretch it out. Okay, I'll just explain some more things for that. Okay. Then we are having increment address. मतलब address का content है actually, and whenever I say address means what, address का content. Okay, and then we are having increment at the rate RP. But in increment we are having one more instruction which is the important one that we used to forget. Okay, it's just like increment DPTR, that is also there. Once again, do not make your own instructions. समझो. ठीक है, we are having increment DPTR, you can see over here, but we do not have decrement DPTR. खुद से instruction लिखने का नहीं. Okay, so in a decrement we are having 4 variations, but in increment we are having 5. That extra one is that increment DPTR, which we do not have in decrement. Fine. So we can only increment DPTR, we cannot decrement it. Keep in mind. Okay, because sometimes in Viva I just ask what is that, what does this decrement DPTR do, and people say हाँ DPTR का जो भी content है decrement by 1. So I just understand कि मतलब ये खुद से instruction बना रहे हैं, इसको instruction set पता नहीं है. ठीक है, and then I will just reduce your marks. Fine. So keep in mind decrement DPTR क्योंकि instruction है नहीं, खुद से बनाओ मत. Fine, I hope you understood this one. Okay, then we are having for the multiplication, because we are in arithmetic group, so that all increment, decrement, addition, subtraction, division, all will come in picture. Okay, so once again in the multiplication we are having one instruction, it's a mul AB. Once again, do not make your own instruction. Do not say like mul A comma R0, mul A comma RR. No, we cannot do. We just have only mul AB. That's it. Okay, so it will just multiply A and B ka content, and answer will be in A and B, wherein B will be having a lower byte and the A will be having a higher byte. That's it. Okay, so keep in mind for the division and the multiplication, we are just having only single instruction. There are not any types DOA comma R0, DOA comma RR, no, or DA comma R dash, no. We just having division AB and mul AB. That's it. Do not make your own instruction. Fine. So this is what we have seen regarding the mul AB, and now we have to just go for a subtraction. So now in addition we have seen two, that add and add with carry. Likewise in subtraction we'll be having what? Come on, guess. Come on, guess it. In addition we have seen two, add and add with carry. Likewise in a subtraction, what we will have? Guys, bolte jao, please.
Subtract with carry.
Yeah, subtract with carry. And do we have a normal subtraction? Subtract SUB?
Yes.
No, that is what, no, it is not there. That is what you have seen in actually practical, no? Okay. So now in a subtraction, we just have only SUBB. Subtract with borrow. This is called as a borrow in our subtraction. Nothing else. Okay. This is a SUBB. So whenever I say SUBB A comma, let's suppose RR. So it will just do A minus RR minus carry. Now once again, this carry is going to be of previous operation. Okay, it's not of the same. Getting it? Okay. So A minus RR comma C. This is what it will be doing. Okay. Now let's suppose if you have to just do A minus RR, then what should I do? I just want to perform this particular operation. A minus RR. मुझे just ये subtract करना है. Previous वाला carry consider नहीं करना है. तो keep in mind we do not have a normal subtraction. ना ये वाला instruction नहीं है. खुद से बनाओ बस. That's why I'm saying again and again. खुद से मत बनाओ. Yes, anyone? If I want to do this particular operation A minus RR, then I will just clear the carry ना. Carry को zero कर देंगे. खत्म. So means what is just as good as this one. Okay, so whenever you want to do the normal subtraction, so what do we do in the programming? Just that before using the subtraction operation, you have to clear a carry. वो carry को कैसे clear करेंगे बाद में देखते हैं. Okay, we are having instruction for that. Okay, so keep in mind subtract SUBB. We are having just only subtract with a borrow. We do not have normal subtraction. But in addition, we are having both add as well as add C. Getting it? Okay, but in subtraction, we are just having only subtract with a borrow. Okay, so it's just like subtract with a borrow A comma RR. That's it. And it will just do A minus RR minus carry. And if you want to do the normal operations, then yes, you have to just clear the carry. That's it. Now here we are having that all the variations, that A comma at the rate RP, then A comma address, and then A comma hash n. These variants are there. Getting it? So just have a look at this particular instruction set. Yeah. So this is all regarding, these are the all 24 instructions which are there in arithmetic. So once again, we are having instruction for add. 4 instructions are there. We are having instruction add with carry. Once again, 4 instruction. Then we are having da. Then we are having decrement ka 4 instruction. Okay. Then we are having division, multiplication. Then we are having increment ka 5 instruction and SUBB ka 4 instructions. So these are all 24 instructions are there in a arithmetic instruction. Fine. Any doubt in any of the instruction? In any doubt in arithmetic instruction? Come on,
No,
ask. पक्का सभी को? I think अकेला नील बोल रहा है. Okay, so that's all regarding the arithmetic instructions we have seen. Likewise, we have to cover 100 instruction. आज try मारते हैं देखने को. Yeah, so arithmetic instruction, I hope you understood. And if you want the details of this instruction now, which is given above, ये just summary है कौन से instruction से. If you want to know all the things regarding it, कैसे किधर store होता है, flag कौन से affect हो गया, and everything, so that will be given above. ये यहाँ पे हर एक instruction का full detail में. ठीक है, notes में just before that. ठीक है, I'm just telling you the summary table. हाँ बोल. Any doubt? Okay, so this is all things are given over here. That हर एक instruction in a detail is given here. Okay, here I'm just taking the summary so that we can finish it fast. Okay, you can just report to that content later on so that you will get more to know. Fine. ये भी ये दिया है but उससे अच्छा नीचे वाला summary है. ठीक है, कितने बाइट का वगैरह इंस्ट्रक्शन दैट इज गिवन ओवर हियर. Okay, yeah. So we are done with the arithmetic. Then the logical. Logicals are very simple. Once again, so logic कौन से operations we can do here? Let's see. So we can just have a and, or, and XOR. These are the only three logical operations which we can perform. And, or, XOR. Then we are having not and all. Then we will see. Let's see. अभी इसमें कौन से variations है? Try to understand. Now let's check for the logical instructions. Yeah. So now the next group of instruction is logical. Okay. So in logical we can perform this and, or, XOR, and not. These are the operations which you can perform. Okay. Now in and we are having 5 type, not 5. 1, 2, 3, 4, 5, 6 type. देखो अभी and में कैसे कैसे. Okay. And that will be repeated in or as well as in XOR. Okay. So let's see. We can just have that and logic. ठीक है. Keep in mind, most of the arithmetic and logical instruction में destination is going to be the accumulator only. हाँ, but logical instruction support address as well. So let's see how which are the different variations are there. Then and logic we can have a comma rr. Okay. Then and logic, this is ANL means and logic. Okay. Then a comma address, then ANL, a comma at the rate RP, then ANL, a comma hash in. Fine. So these are all the normal variations which are seen in arithmetic also. So RR, address, at the rate RP, and hash in. Okay. Now there are two more things which are there only in a logical, not in arithmetic. There is an ANL address. Now the destination can be address as well. So we can just reverse this instruction. ये इसमें allowed है, just logical में allowed है, arithmetic में नहीं. Do not make your own instructions. समझो. ठीक है? And we can have like ANL address comma hash n. So these are the two instructions which are more in logical instructions. Fine. So these are the logical instructions. So whenever the AND logic, what will happen? It will just add the content of A with the RR ka content. Fine. And what are the answer? It will store back to the accumulator. Getting it? So likewise, we are having that variations in OR as well as in XOR. Okay. So these 6 instructions are there in OR as well as in here. So we have seen an 18th instruction. I hope you all are getting it. कुछ भी doubt रहेगा तो please interrupt me. Okay. So these are the logical instruction, and we are having some more. That is a CLR. Okay. We are having CLRA. So it will just make that accumulator 0. Fine. Then we are having CPLA. That is a complement A. So complement means what? What does complement do? What does complement do? What do you mean by
convert
complement?
high to low and low to high.
Yeah, it will just convert 0 to 1 and 1 to 0. That's it. That is what the complement. Okay. Or you may say that A to the A bar. Fine. So we are having two more instructions. That is a clear A. Means what we just make A as a 0 0, and complement A means what? जिधर भी 0 इसको 1 कर, जिधर भी 1 है उसको 0 कर. Fine. So these are the two clear and complement one. They just come under the logical instruction. Now some more. Let's see. Yeah, this many. Okay. So likewise, we have seen that, and we are having OR. So OR के 6 instruction you can see. किधर है? Yeah, or A comma RP and address वगैरह and दो पहले. ठीक है. Likewise, we can have it for the XOR. I hope everyone knows that. What is the XOR का table? I don't know. 0 0. What is the answer? 0 1. What is the answer? 1 0. What is the answer? 1 1. What is the answer? What is the XOR का table? I want it from you. XOR का table का 0 0 answer will be what? Yes, 0 0 answer is what? 0 or 1?
0.
0.
Okay. Pakka? Everyone?
Yes.
Okay. 0 1.
1.
1 1 0.
1.
And 1 1.
0.
0. Getting it? So this was the XOR operation. That is what it is going to do. Getting? So in XOR also we are having that all the 6 types. Okay. Then we are having some extra, that is NOP. Now NOP is also there in logical instruction only. ठीक है. NOP means of no operation. ये कुछ काम नहीं करता. Just PC से increment होता है. जो program counter है वो just next instruction पे जाएगा. बाकी कुछ नहीं. बाकी ये कुछ काम नहीं करता. But though it doesn't do anything, ये बहुत काम की चीज है NOP. ये बहुत काम की चीज है एक्चुअल में. ठीक है. So just like NOP, just do that PC में कुछ काम नहीं करके ऐसे no operation, literally it will just go to the next instruction. खत्म. Fine. So NOP. Then we are having some logical instruction like, yeah, RLA. RLA means what? Rotate left accumulator. Getting it? Rotate left. Now I hope you remember that rotate wala instruction which you are done in 886. Okay, so rotate left accumulator means what? Accumulator है. ठीक है, लेफ्ट मीन्स व्हाट, एक एक बिट लेफ्ट में जाएगा. गेटिंग इट? ठीक है, या जस्ट लाइक दिस वन. अभी A0 जाएगा A1 में इधर ऐसा. ठीक है, एंड इट्स अ कंप्लीट रोटेट. ठीक है, सो मींस व्हाट, दिस A7 विल गो इन A0. समझे, इधर का जो बिट रहेगा दिस विल गो इन A0. फाइन. ठीक है, बिकॉज accumulators of 8 bits, so that's why I'm saying that A0 A1 A2 up to the A7. ठीक है, whenever I say the RL means rotate left accumulator, तो फिर ऐसा रोटेट होगा ये जो A7 है A0 में जाएगा. ठीक है, so that is what is written over here. Try to understand. Okay, so it's just RLA में होता क्या है, here the explanation in short it is given. Yeah, so that RLA you can see that A0 will go in A1, A1 will go in A2, likewise then A6 will go in A7 and A7 will go to the A0. ठीक है, then likewise we are having RLCA, rotate left with a carry. So whenever I say rotate left with a carry means होगा क्या, अभी जो A7 जो इधर जा रहा था पहले वो कैरी में जाएगा अभी इधर ऐसा, और कैरी इधर आएगा. That is what the rotate left with the carry. ठीक है, so that is called the RLCA. So you can see over here, what does it say? So that carry will come in A0, यहाँ से in A0, then A0 will keep on shifting and the A7 will go to the carry. Getting it? ठीक है, so that is what the rotate left accumulator with the carry. Likewise, we are having rotate right and rotate right with the carry. Fine. So these are the two more instructions which we are having. Rotate right and rotate right with the carry. And the last we are having is swap A. अभी swap A क्या होता है? Swap A. It is just sort of swapping. Now you will say that swapping will actually be required two things, but यहाँ पे accumulator है. So if we just do swapping in accumulator itself, it's just like it will just swap that higher and lower neighbor. Means what? Let's suppose previous to this swap A instruction, my A ka content is 32, and if I just say swap A, what will happen? Anyone just can guess it? Swap A. If I say swap A, what will happen? My A ka content will be after this instruction. If I execute this one, so yes, it's going to be the 23. That is what it is going to swap this lower neighbor and the higher neighbor. You A को ही swap करेगा. Getting it? ठीक है, so 2 इधर आ जाएगा, 3 इधर आ जाएगा. That is what the swap है. Ready? So we have seen the logical instructions. So in logical we are having AND or XOR, इसमें 6 types. ठीक है, then we have seen we are having some extra. There is a CLR, then CPL. Fine. Then we have seen that rotate instruction, rotate left, rotate right. इसमें दो instructions, and we have seen this NOP also and swap. ठीक है, so these are all logical instructions. So we have just completed half of the part. 50 instructions खत्म. ठीक है, so I think 25 there in arithmetic and 25 there in 24 there in arithmetic and 26 there in logic. So 50 instructions we have done. Okay, then let's see this one next. They are easy. That is what we have done in addressing mode. Then move wala instruction, data transfer instruction. Okay, so I hope everyone knows this one. Then A comma RR, then A comma address, A comma that RP, A comma hashing. Now you can just relate this one. Sorry. Yeah. So you can just relate this one with whatever we have done in addressing mode. Fine. So I hope there should not be any difficulty in this one. Move A comma RR, move A comma address, move A comma that RP. Any doubt? Just go through this move instructions. Everyone just please go through this one. I will zoom it a little bit. Move instruction. If you have any doubt, then ask. That simple one that we have seen. Addressing. We have covered actually all in addressing mode. So I just want you to just go through it. Any doubt? So whenever I say the move repeater comma hash double n. Now double n means what? You have to move a 16-bit ka data. It's not 8-bit, it's 16-bit because my repeater is of 16-bit. So that's why the double n is given. Okay, and this is the instruction which you have seen, that move C and move X. So whenever I say the move C means what? We want to move it from external ROM, and whenever I say the move X, we want to move the data from external RAM. And if you just simple move, there is an internal things, internal RAM and internal जो भी है. Fine, is for internal move. Any doubt in a move instructions? Come on. Any doubt?
No doubt, sir.
कुछ डाउट है तो प्लीज आस्क. आई एम जस्ट मेकिंग थोड़ा सा हरी बिकॉज अपना सिलेबस बहुत पीछे है यार, नवंबर में खत्म करना है. ओके, नो प्रॉब्लम. Yeah, so these are some more moving instructions that we have seen, move x, comma, repeater and all. Okay, yeah. Then we are having this pop and push. Fine. Now pop and push, they are similar to the 8086 only, but what is the difference is that here in a pop and push we are having the instruction like this one, pop address and push address. You can see. So these are the only two instructions which we have. So pop and push, it will just push the address ka content only, not any other register ka content. समझो. पॉप एंड पुश इंस्ट्रक्शन मतलब जो भी काम करेगा एड्रेस के लोकेशन का जो भी कंटेंट उधर ही काम. It will not relate to the any register or any accumulator or variation. No, it is like pop address and push address. Okay, so if I just give you the example, which is works like this one. So whenever I say the pop, let's see, or whenever I say the push, okay, push address. So instruction will be push 30h. Then what this instruction will do is that keep in mind now in 8051 the stack point ka content is a 07h by default. It is just pointing to 07h internal RAM. Because in internal RAM we know it's ranging from 0 to 7F and somewhere we are having a 07 as a location. Okay, so SP will be pointing to the 07H. Now whenever the push 30H, what will happen is that whatever the content at 30H, 30H में जो भी content, let's suppose 20, that will get push. मतलब अभी push क्या करता है पहले कि SP will get incremented by 1. इसको increment करेगा. पहला push का काम क्या रहता है? पहला increment SP and then write. That is what the function of push. समझो 8086 का पुश और ये पुश में अलग है, डिफरेंस है. 8086 का पुश क्या करता था, डिक्रीमेंट करता था एसपी, वो उल्टा भरता था. ठीक है, उसके बाद राइट करता था. राइट टू अंडरस्टैंड दोनों में डिफरेंस है 8086 और इसके पुश में. ठीक है, 8086 के पुश में वी यूज्ड टू डिक्रीमेंट एसपी एंड देन वी यूज्ड टू राइट. ठीक है, बट यहाँ के पुश में फर्स्ट इट विल इंक्रीमेंट एसपी. व्हाई इंक्रीमेंट? बिकॉज़ इधर नीचे कम जगह है, बहुत कम जगह भी नहीं, मतलब वाइट इज 07, इसके पीछे भी बहुत सारे रीजंस है, बट इतना डिटेल में फिलहाल तो नहीं जा रहा हूं मैं. या सो हियर इट इज अ बैंक 0 जिसको मुझे हाथ नहीं लगाना है. Okay, so that's why the SP is 07. Why? Because whenever you will start writing, first of all, it will get incremented. So it will just point to the 08. So first location in which we are going to write the content by using the push operation is going to be the 08, not 07. So that's why 07 पे point करते हैं. ठीक है, and whenever the push operation पहले increment करेगा and उसके बाद it will just write it. ठीक है, means so whenever I say that push 30h, so what will happen is that if my SP का content is 07, so what is the content of the 30th location that will get written at this particular location 08. ये 08 location पे इधर लिख देगा. Fine. Likewise, we are having a pop address. Now, let's suppose if I say the pop 40h, pop 40h, ठीक है. अब इसका मीनिंग क्या है कि स्टैक पॉइंटर जिधर भी पॉइंट कर रहे हैं. ठीक है, सो यहाँ पे पॉप का मीनिंग क्या है? पुश मींस व्हाट वी आर राइटिंग इनटू द स्टैक एंड पॉप मींस व्हाट वी आर रीडिंग फ्रॉम द स्टैक. ठीक है, सो व्हेनेवर आई से द पॉप मींस व्हाट, pop 40h, this is what the instruction, because we can have only address over here, we cannot have any other register. समझो. Right, so whenever I say the pop 40h, what will happen is that wherever that SP is pointing, सपोज यहाँ पे, तो इसका जो भी कंटेंट है इट विल पॉप इट एट 40 लोकेशन, मतलब 40 लोकेशन पे वो कंटेंट कॉपी करेगा, वो रीड करेगा उधर, मतलब जाके लिखेगा. ठीक है, सो व्हेनेवर से द पुश मींस व्हाट वी आर राइटिंग इनटू द स्टैक एंड व्हेनेवर से द पॉप मींस व्हाट वी आर रीडिंग फ्रॉम द स्टैक. आई होप यू ऑल आर गेटिंग इट. अंडरस्टूड? सो नाउ इन दिस केस व्हाट हैपेंस दैट फर्स्ट ऑफ ऑल व्हेनेवर से द पॉप, फर्स्ट इट विल रीड द डेटा एंड उसके बाद इट विल डिक्रीमेंट एसपी बाय 1, और यू मस्ट नो एसपी इज इक्वल टू एसपी माइनस 1 एंड हियर एसपी इज इक्वल टू एसपी प्लस 1. Getting it? Okay, it will do that, decrement the SP by 1 after read operation. So that is what the push and pop will do. Fine. So these are the two more instructions which are there here in more data or you may say the data transfer instruction or data move instruction. Okay, then we are having some easy instruction like exchange. Is XCH, that is the exchange. So whenever we want to exchange the data, so here we can use this one. Okay, so exchange A comma RR, exchange A comma address, exchange A comma address, RPI and all. Fine, you can just check it out. Fine. Exchange whether XCHDA comma RP is a different one. So here we are just changing only LSB, or you may say that lower nibble only. Fine. Here we are just moving that entire 8-bit content, but here when I say XCHD, okay, if I just apply the D means what? Here we can use only A comma RP, and here we can just change only that lower nibble, not that entire 8-bit. समझो. Fine. So these are all that data transfer instructions are there. Fine. Now the next one, which are important one, let's see. Call and jump instruction. Next set of instructions is a call and jump. Fine. So here we are having a call. अभी what is the function of this call instruction? Try to understand. पहले call समझो, उसके बाद बाकी सब समझो. Just start the page. Yeah. ये कौन सा फाइल है? Let me try. Yeah. So call instruction. Chagre. Okay. What the function of call instruction is that now if I return some program like move a comma r0, add a comma r1, then anything jnz r2 जो भी है, sorry jnz अब किधर तो रहेगा let's suppose, ठीक है, then I have return की x और a comma 30h कुछ भी रहेगा, ठीक है, and let's suppose here we are having that call instruction, ठीक है. अभी समझो कॉल एंड जंप में फर्क है. आई होप यू अंडरस्टैंड व्हाट इज द डिफरेंस इन कॉल एंड जंप. एनीवन नोस? मैंने बताया था कॉल एंड जंप में फर्क है. एनीवन नोस व्हाट इज द डिफरेंस इन कॉल एंड जंप? लेट्स सी व्हाट इज द डिफरेंस इन कॉल एंड जंप. ठीक है, लेट्स सी. अभी कॉल का फंक्शन क्या रहता है? इट इज एक्चुअली यूज्ड टू कॉल सम सबरूटीन व्हिच इज जस्ट आउट ऑफ द प्रोग्राम. कुछ तो अलग प्रोग्राम लिखा है, उसको मुझे एग्जीक्यूट करके आना है. ठीक है, सो फॉर दैट पर्पस आई विल बी यूजिंग दिस कॉल. Getting it? So what is the function of call is that? Try to understand. So whenever I say the call instruction, it will just go to the another program wherever we have written that label. Let's suppose call if I'm saying next. Okay, and next label is over here. Fine. So it will just go over there. It will execute that, and once again it will just come back to the next instruction. That is what is the function of call. ठीक है, समझो कॉल क्या करता है. कॉल मींस व्हाट? आई जस्ट वांट टू कॉल सम सब रूटीन. इट जस्ट लाइक नॉर्मली आप सी में कैसे फंक्शन कॉल करते हो वैसे. Fine. So it's just like call and the function मतलब जो भी लेबल दिया रहेगा उस लेबल पे जाएगा. ठीक है, but what is the important thing regarding the call is that it just go to the thing, it will just solve that whatever the thing is there, मतलब it will just do that program subroutine, it will just execute the subroutine, and after that we'll be having that return instruction, not just only return, not return. ठीक है, and because of this we just come back to the नेक्स्ट इंस्ट्रक्शन ओवर हियर. मतलब कॉल के बाद जो भी नेक्स्ट इंस्ट्रक्शन रहेगा वहां पे आएगा. ठीक है, बट इफ आई इंस्टेड ऑफ दिस वन कॉल, इफ आई जस्ट यूज जंप, JMP. ठीक है, जंप once again if I say next instead of the call, if I just say jump next. ठीक है, so jump will also go there, it will execute but it will not return back. jump return नहीं आता है. समझो व्हाट इज द डिफरेंस इन कॉल एंड जंप. कॉल क्या करता है? जाएगा, सॉल्व करेगा, बाद में रिटर्न भी आएगा. बट जंप क्या करता है? जाएगा, बस उधर का ही हो जाएगा, उधर का काम खत्म, उधर वो खत्म कर देगा, फिर से रिटर्न नहीं आने वाला. So there is a no provision in coming back in a jump, and call may we just come back to the home. That is what the main difference in jump and call. Understood? Okay. So now here you can see. Now what happens is that now as I told in a call, so it just jump back to the next instruction. But how it will jump? It's just simple. इसका जो भी instruction का जो address है SP+2, जो भी मतलब sorry PC+2, जिधर भी मतलब ये point करता रहेगा, जो भी ये लोकेशन पे एड्रेस है, सॉरी जो भी लोकेशन पे इंस्ट्रक्शन स्टोर्ड है, दैट लोकेशन विल गेट स्टोर्ड इनटू द SP. सो व्हेनेवर इट इज गोइंग टू दैट पर्टिकुलर इंस्ट्रक्शन, बिफोर दैट इट विल परफॉर्म दैट पुश ऑपरेशन. तो ये जो भी एड्रेस है वो पहले पुश करेगा. मतलब जब रिटर्न आने का मुझे, तो मुझे पता होना चाहिए किधर रिटर्न आने का है. ठीक है, सो फॉर दैट पर्पस व्हेनेवर द कॉल इंस्ट्रक्शन, सो बिफोर गोइंग टू द सबरूटीन, फर्स्ट ऑफ ऑल इट विल पुश द नेक्स्ट इंस्ट्रक्शन का लोकेशन. गेटिंग इट into this stack memory by using a push. Guys, कुछ नहीं समझ रहे तो पूछो. I am just taking advantage of 86 is done, so that's why I'm going थोड़ा सा fast. ठीक है, I hope that the concepts of push and pop and everything is clear to you. So that's why मैं थोड़ा सा fast जा रहा हूँ. But if you feel कि सर नहीं समझ रहा तो फिर stop करूँगी. Okay, so once again call का function क्या है? If we just go to the subroutine, solve करेगा, रिटर्न आएगा. रिटर्न आने के लिए क्या वो एड्रेस चाहिए ना, तो ये क्या करेगा? कॉल जब जाने के पहले वो पुश करता है एड्रेस, सो दैट रिटर्न आने कुछ प्रॉब्लम ना हो. ठीक है, बट जंप क्या करता है? कुछ नहीं, जंप सिर्फ जंप मारने का काम करता है. ये रिटर्न आने का वगैरह बंदोबस्त कुछ नहीं करता. वो जब जाएगा, जिधर बोलेगा उधर जाएगा, एंड खत्म, उधर काम खत्म करेगा. दैट्स इट विल स्टॉप हियर ओनली. इट विल नॉट जंप बैक टू द मेन प्रोग्राम. ठीक है, ठीक है. तो मतलब कैसे? इफ आई जस्ट एक्सप्लेन द कॉल, इट जस्ट लाइक दिस वन. मेन प्रोग्राम चालू है, यहाँ पे कॉल आया, सो इट विल जस्ट गो टू द सबरूटीन, सॉल्व करेगा, एंड वी जस्ट कम बैक बिकॉज हियर विल बी हैविंग अ रिटर्न. ठीक है, एंड इट विल जस्ट सॉल्व द प्रोग्राम. ठीक है, बट इफ आई से जंप, प्रोग्राम है यहाँ पे, जंप आया, इट विल जस्ट गो देयर एंड खत्म, उधर ही रुकेगा, वो आएगा नहीं रिटर्न. समझ में आ रहा है क्या? गेटिंग, इधर रुके, वो रिटर्न नहीं आएगा. ट्राई टू अंडरस्टैंड दिस डायग्राम्स. बिकॉज ऑफ दिस वन यू जस्ट अंडरस्टैंड द डिफरेंस बिटवीन द जंप एंड अ कॉल. Okay, so now in a jump and call there are three types, मतलब different types are there. Now in a call we are having a call and L call. ये दो instructions है. We do not have a simply call instruction. We are having a call and L call. अब ये क्या फर्क है? Now whenever the a call is absolute call and whenever the L call is a long call. So this is what it is used in the range of 2 kb. मतलब तेरा का सब रूटीन मतलब जहां तूने कॉल इंस्ट्रक्शन लिखा है, ठीक है, एंड अगर तेरा सब रूटीन इज इन द रेंज ऑफ 2 kb देन विल बी यूजिंग a call, दैट इज एब्सोल्यूट कॉल. A means absolute, ठीक है, एंड इफ योर सब रूटीन इज देयर एनीवेयर इनसाइड द 64 kb, ट्राई टू अंडरस्टैंड, एनीवेयर इनसाइड द 64 kb मतलब बहुत लंबा है, तो इन दैट केस आई विल बी यूजिंग अ लॉन्ग कॉल. समझो, इफ योर सब रूटीन इज नियर बाय ओनली द प्रोग्राम विद इन द रेंज ऑफ 2 kb, ठीक है, then I'll be using a call. But if it is you do not know and is anywhere in that external ROM, then in that case I'll be using a L call. So that's why the name is A means absolute, pass me जाना है, L call means so long call means we can just move anywhere in a memory. ठीक है, likewise in a jump also we are having a three instruction. There's a S jump, A jump, and L jump. Getting it? So keep in mind in a jump we are having three. There is a S, A, and L, and in call we are having the A and L only. ठीक है, so whenever the H jump means what, it is just in range of +28 to -127. इतने बाइट में अगर रहेगा मतलब इसके मतलब आगे पीछे किधर रहेगा तो आई बी यूजिंग अ शॉर्ट जंप. ठीक है, once again if you to jump somewhere in 2 kb का range then I'll be using a jump, and if you want to jump in 64 kb का range then I have to use that L jump. Fine, so S, A and J. So whenever I say the S, it is for +128 to -127 वो particular range में 0 to B में, ठीक है. Whenever I say A, it is for the 2 kb, and whenever I say the L, it is for 64 kb. Getting? So this is what two we are having. There is a call and jump. What is the difference between these two? Call फिर से return main program पे आता है, jump फिर से return नहीं आता. I hope you understood. And now just come to this one. Now you will understand this. Okay, these are something different instructions than the 886. Okay, so here you can see a call address. Okay, so when was the a call, the address is going to be the short address. ठीक है, अब डिपेंडिंग ऑन दिस वन अपने एड्रेस के भी टाइप है. एड्रेस अपन नॉर्मल में देखें, ठीक है, देन एल एड्रेस मतलब लॉन्ग एड्रेस, आर मतलब रिलेटिव एड्रेस, एंड एस मतलब शॉर्ट एड्रेस. ठीक है, आर एड्रेस आता है व्हेनेवर देयर इज अ शॉर्ट जंप, एस एड्रेस आता है व्हेनेवर इज अ ए और यू मे से एब्सोल्यूट जंप, एंड एल एड्रेस आता है जब व्हेनेवर इज अ एल कॉल. ठीक है, एल कॉल और एल जंप. ठीक है, so these are the three addresses are there. Once again, R address मतलब relative address, S मतलब short address, and L address मतलब long address. ठीक है, इसके भी मीनिंग है बट इसके फिलहाल तो डिटेल में मैं नहीं जा रहा हूँ. फाइन, सो कीप इन माइंड एस एड्रेस सॉरी आर एड्रेस कब यूज होता है, व्हेनेवर आई एम यूजिंग द एस जंप, मतलब शॉर्ट वाला रहेगा तो आर एड्रेस रहेगा. ठीक है, व्हेन इज द एब्सोल्यूट कॉल और एब्सोल्यूट जंप आई एम यूजिंग एस एड्रेस, और व्हेनेवर इट इज द एल कॉल और एल जंप लॉन्ग रहेगा तो एल एड्रेस आएगा उधर, मतलब जिधर भी जंप करना है वो एड्रेस एल एड्रेस रहेगा. ठीक है, फाइन, सो हियर व्हेन इज द ए कॉल द एड्रेस विल बी एस एड्रेस. ठीक है, या नाउ वी आर हैविंग समथिंग लाइक सीजेएन. अभी सीजेएन मतलब क्या, ट्राई टू अंडरस्टैंड अभी ये चीज क्या है, ट्राई टू अंडरस्टैंड. ठीक है, सीजेएन, सीजेएन मींस व्हाट, कंपेयर जंप इफ नॉट इक्वल. आई विल जस्ट टेक दिस इंस्ट्रक्शन ओवर हियर सो दैट यू कैन अंडरस्टैंड बेटर. यार हैंग मत हो. So come here, let's see the next instruction. That is a CJNE. Guys, lecture important time. We are covering a lot. CJNE A comma address comma address. ठीक है, अभी इसका मीनिंग क्या समझो. CJNE means what? Compare jump if not equal. Compare jump if not equal. So what this instruction wants is that try to understand. It's just like compare means what, मुझे दो बंदे चाहिए जिसको मुझे कंपेयर करना है. ठीक है, so there are two बंदास are A and address. मतलब A का कंटेंट you have to compare with the address का कंटेंट. Keep in mind once again we cannot make our own instruction. मतलब कंपेयर के लिए इधर कुछ भी मत डाल. We are having A and address and बाकी जो भी मतलब टाइप से वही यूज करना पड़ेगा. We cannot use something else. ठीक है, so CJNE compare jump if not equal. So we can just compare the A का content with the address का content. If they are not equal, then we have another one which is the location where we have to jump. समझो, so whenever से CJNE कंपेयर करने के लिए दो बंदे चाहिए और जंप करने के लिए मतलब जिधर जंप करना है वो एड्रेस चाहिए. ठीक है, सो वी आर हैविंग ए एंड एड्रेस. इन दोनों में जंप मतलब कंपेयर कर ए का कंटेंट विद द एड्रेस का कंटेंट, एंड अगर दोनों अगर नॉट इक्वल है देन यू हैव टू जंप टू दिस पर्टिकुलर एड्रेस. ठीक है, सो अब ये सिंपल वाला जंप है तो यहाँ पे आर एड्रेस रहेगा, दैट इज द रिलेटिव एड्रेस. गेटिंग इट? ठीक है, सो द सीजे एनी कंपेयर जंप इफ नॉट इक्वल, इन दोनों को कंपेयर कर, तो दोनों कंपेयर नहीं तो यहाँ पे जंप मार, फाइन. ठीक है, लाइकवाइज सीजे एनी में वी आर हैविंग अ डिफरेंट टाइप, दैट इज सीजे एन ई. We can just compare like a comma hash n, sorry, a comma hash n and then r address. ठीक है, and we can have cj any rr मतलब any register comma hash n and then r address. ठीक है, and we can have cj ne at the rate rp comma hash n and r address. ठीक है, so these are the only available instruction with the cj any. खुद का इंस्ट्रक्शन मत बनाओ, मतलब ऐसा मत करो कि एड्रेस कॉमा rr एड्रेस कॉमा rp, नो, खुद का मत बनाओ. ठीक है, सो दिस आर द इंस्ट्रक्शन व्हिच आर देयर इन सीजीएनए. तो सीजीएनए मतलब ये दोनों को कंपेयर कर, अगर इक्वल नहीं है तो इधर जंप मार. ठीक है, लाइकवाइज वी हैव डीजेएनजेड, वन मोर इंस्ट्रक्शन डीजेएनजेड. नाउ व्हाट दिस विल डू, एनीवन? डीजेएनजेड, सो डीजेएनजेड मींस व्हाट, डिक्रीमेंट जंप इफ नॉट 0, डिक्रीमेंट जंप इफ नॉट 0. नाउ डिक्रीमेंट मींस व्हाट, कोई तो एक बंदा रहेगा उसको ही डिक्रीमेंट मारना है, तो मतलब मुझे वो डिक्रीमेंट वाला बंदा चाहिए. ठीक है, और उसके बाद अगर वो 0 नहीं है तो मुझे जंप किधर मारना, वो एड्रेस चाहिए. खत्म. सो वी रिक्वायर दिस टू थिंग्स. ठीक है, कीप इन माइंड सीजीएनए में रिक्वायर 3 थिंग्स. व्हाई? कंपेयर करने तो 2 बंदे चाहिए, एंड अगर मतलब वो कंडीशन सेटिस्फाई हो तो जंप करने के लिए वो एड्रेस चाहिए. ठीक है, बट इफ आई से डीजेएनजेड वंस व्हाट, वो पर्टिकुलर थिंग को डिक्रीमेंट मार, रजिस्टर या लोकेशन जो भी है. ठीक है, अगर वो 0 नहीं है तो फिर जंप मार, सो दैट्स वी रिक्वायर एड्रेस. ठीक है, सो हियर वी रिक्वायर द 2 ऑपरेंड्स. फाइन, सो डीजेएनजेड मींस व्हाट, इट्स जस्ट लाइक डीजेएनजेड इंस्ट्रक्शन इज लाइक rr comma address. ठीक है, सो डीजेएनजेड दैट पर्टिकुलर मतलब डिक्रीमेंट दैट पर्टिकुलर रजिस्टर, एंड अगर वो 0 नहीं है तो फिर ये एड्रेस पे जंप मारेगा. I hope you are getting it. So that is what a DJNZ. So likewise in a DJNZ we are having a different one more type, the DJNZ. There we can decrement register or any address ka content, and we can just jump to the address where we want to jump. Fine. Okay. And then as I told, we are having the L call. L call matlab here we have seen A call, then here we are having L call, then A jump, L jump and S jump. Okay. Why? Just keep it in. Just keep remember like this one. Call में we are having two, A call and L call. Fine. And jump में we are having S A L. So S jump, A jump and L jump. Fine. तो ये 5 instructions. This is what the A call. Then this is what L call. Then A jump, L jump and S jump. Fine. ठीक है. And these are all the conditional jump. This is what we have seen the conditional jump. CJNE and DJNE. That's the conditional jump. ठीक है. I hope you are getting it. Because this is only the tricky part in the instructions. बाकी सब easy. ठीक है. Let's move forward. Then we are having this jump. ये डायरेक्टली जंप वाला इंस्ट्रक्शन है, जंप एट द रेट प्लस dptr. तो वो इसमें क्या बोलते हैं, रॉम में वगैरह जंप मारने के लिए यूज होता है. देन जंप, जंप इफ कैरी, जंप इफ नो कैरी, जंप इफ बोरो, जंप इफ नो बोरो. So these are the instructions are there. Getting it? Fine. Jump if carry, jump if no carry. ठीक है. And this is what, it's not jump if borrow, sorry, it is a jump if no bit or jump if bit. It is a bit, मतलब it is checking the single bit. ठीक है. This is what jump if carry, jump if no carry. But this is what JB means what jump if bit. अगर वो B मतलब ये जो भी bit जो specify किया है, ठीक है, अगर वो अगर 1 है और इमेज से जंप मतलब 1 है, then we have to jump to that particular address. ठीक है. And if I say jump if no bit means what, if this particular bit is 0 तो इस particular location में जंप मारना है. ठीक है. देन वी आर हैविंग अ जेबीसी, दैट इज जंप इफ बिट एंड कॉम्प्लीमेंट. मतलब जंप कर, अगर वो बिट अगर 1 है तो जंप कर, उसके बाद इसको कॉम्प्लीमेंट भी कर, मतलब वो 0 रहेगा तो उसको 1 कर. गेटिंग इट? ठीक है. सो जंप इफ बिट इफ कॉम्प्लीमेंट, तो इट इज लाइक जंप इफ बिट अगर वो 1 है, जंप इफ बिट मतलब अगर वो 1 है तो जंप मारने का. ठीक है. एंड जंप मारने के बाद उसको 0 कर, सॉरी इसको 0 कर, आई एम जस्ट करेक्टिंग माय सेल्फ वंस अगेन. जंप इफ बिट एंड सी मींस व्हाट इज अ कॉम्प्लीमेंट. जंप इफ बिट एंड देन कॉम्प्लीमेंट. अगर वो बिट अगर 1 है तो इधर जंप मार, उसके बाद उसको 0 कर, कॉम्प्लीमेंट है तो उसको 0 कर. ठीक है. then we are having jz jump if 0 and jump if no 0. ठीक है. guys these instructions are important. ये jc sorry jb jnb and jbc, these are something different which you are not seeing. So they are only for a single bit instruction because our 8051 is a bit addressable as well. So we are having some bit instruction also. तो ये bit instruction है. ठीक है. this operate on a single bit. Fine. So it's a jump if bit, jump if no bit and jump if bit then complement. These 3 variations are there. And these are the normal things, that is a JZ, JNZ, jump if 0, jump if no 0, and return from interrupt. Okay, this is a return which is used in a normal subroutine, and this is what is used in interrupt ka subroutine, RATA. Fine. Okay, And the last instruction set, there's a boolean. Boolean means what, they are only on a single bit. That means just work on a single bit. That is a boolean instruction set. So we are having and logic. So and C comma B, the carry flag. We can just and with any other bit, single bit. Okay, boolean means what, it works on a bit, not on a byte. And our 8051 support the bit operation as well. Okay, so we are having and C comma B, then and C comma B bar, मतलब उसका complement करके उसके साथ and करा. Okay, then CLRC. Now this is the instruction for the clearing a carry. Now we have seen in subtraction SUBB. Okay, what I told, if you do the normal subtraction, so before that you have to clear a carry, and that can be done by CLRC. Okay, likewise, if you want to clear any particular bit, so that is also possible. We can use CLRB. We can just whichever the bit address was, that bit can be written over here. So वो 0 हो जाएगा. ठीक है. And the last part, some more instruction, some little bit. Yeah. So we are having complement C, मतलब C को complement करने का, we are having complement B, B को complement करने का. ठीक है. Then we can just use this OR operation also, easy. Then move C comma B, मतलब ये जो B का content है वो we can just take it in C also, carry में भी ले सकते हैं. और we can just have the B comma C, तो carry का content भी B मिला सकते हैं. ठीक है. And we have seen how to clear the things, but likewise we can just set also. अब set के लिए instruction है set B. ठीक है. कीप इन माइंड, सिंगल बिट अगर क्लियर करना है तो इंस्ट्रक्शन है CLR, पर अगर सेट करना है तो इंस्ट्रक्शन है सेट B, एंड उसके बाद जो भी बिट रहेगा वो लिखो, अदरवाइज कैरी. समझ में आ रहा है? कैरी, इट्स नॉट एन, इट्स कैरी. ठीक है. सो टू सेट इट वी आर हैविंग सेट B C, मतलब वो पर्टिकुलर कैरी को सेट कर, एंड सेट B वो पर्टिकुलर बिट को सेट कर. सो कीप इन माइंड, सेट करने के लिए इंस्ट्रक्शन है सेट B, एंड क्लियर करने के लिए वी आर हैविंग CLR. फाइन. सो दिस आर ऑल 110 इंस्ट्रक्शन व्हिच यू हैव सीन. 110 इंस्ट्रक्शन देखे अपन ने. ठीक है. And that will help you in your programming, in your practical, and wherever you just see that assembly program, ये सब picture में आएगा. And once again, do not make your own instruction. ये जो instruction set available है उससे ही करना है. And if you have to go in more detail, so इसके पहले वाले pages आप refer कर सकते हो. Fine. That is all from the Mozilla, which is a very good book for the 8051. For the 8051, you can just refer to the Mozilla, and that's it. That's enough. Fine. Any other doubt? Let me take the attendance because my attendance नहीं लिया. So 1 hour we have just seen only instruction set, and we have just completed it. It's 110 instruction we have seen. I know थोड़ा सा fast दिया, but yes, मतलब just पता होना चाहिए, वो important है. बाकी डिटेल में आप पढ़ सकते हो. Fine. Any doubt? Any doubt?